I am Dr. R. Muthukumaraswamy, Professor and Head, Department of Applied Mathematics, Sri Venkateshwara College of Engineering. Now I am going to explain the problems, how to apply even and odd function. Our focus now on even function, especially very standard problems. Even and odd function in Fourier series. Now we are going to solve one problem using even and odd function. Let us take first case even. Okay, find the Fourier series for f of x equal to mod x in the interval minus pi to pi. Hence deduce that this numerical series. Okay, so what is the range? The range is upper minus lower, so 2 pi. The function is well defined. As you know very well, if any function defined minus a to plus a equal interval, then we can think of the properties of even and odd function. So in order to reduce the number of integrals in Fourier coefficients. Okay, in this case we want to check what type of function fx is modulus x. You know how to define the modulus function. The function is x in the positive of, the function is minus x in the negative of. You know the graph of the function is like 45 degree from x-axis, 45 degree from y-axis. It passes through the origin. This side is function x and minus x. So our interval restricted to minus pi to plus pi. Okay, now I am going to check what type of function. This is given to you, feed minus x, you know modulus of minus x equal to mod x is same as plus x, or otherwise you take the function in the positive of. Give minus x, you will get the other side. Yes, that is, we can check other way around also. Therefore, it is confirmed function is even. If the function is even, you know the Fourier series f of x equal to a0 by 2 plus sigma n equal to 1 to infinity an cos nx. So what is a0? So a0 is 2 divided by pi integral 0 to pi a function of f of x dx. Okay, here the function is in the positive of 0 to pi. It's also already in the formula. So I am going to take the function f of x here in the positive of just x. So just integrate this function x 2 by pi. So integral x square by 2. If I substitute the limits, then you know you will get only the upper limit. The lower limit completely 0 to get cancelled out. Therefore I am going to substitute x equal to pi, pi square by pi, you will get simply pi. So a0 is pi. Next, let us calculate an. 2 by pi integral 0 to pi f of x cos nx dx. So you know very well what is your function in the positive of 0 to pi x cos nx dx. 2 by pi, and x is u, second function is v. Apply Bernoulli's formula. X as it is, integral cos sin nx by n minus derivative of x is 1 and integral sin minus cos nx by n square. So the limits are 0 to pi. The limits are integer multiples of pi. So wherever sin, you can check 0. Sin n pi 0, sin 0. So just ignore this. Minus into minus plus. Yes. So you can rewrite cos nx by n square. I have adjusted the negative symbol. Now substitute after taking out all this denominator completely. Upper limit cos n pi minus 1 power n. Lower limit cos 0. So I can refine further by varying the values. Just take y because we end up with oscillating sequence and minus 1. If I give n equal to 1, this entire bracketed value minus 1 power 1 minus 1, so minus 2. So you'll get minus 4. Put together numerator. This value around minus 2. If I give n equal to 2, this term minus 1 whole square minus 1 0. So all odd value, this bracketed expression is minus 2. So minus 4 by pi n square if n is odd. All even combination, so my an is 0. Therefore my Fourier series mod x a naught by 2, so pi by 2. I am going to substitute this. You can take it at all constant including 4 as well as pi. Take all value, the summation, you know the Fourier series, just feed only odd values, n equal to 1, 3, 5 etc. infinity 1 by n square cos nx. Okay, now I want to deduce the numerical series. If I know the Fourier series, I want to deduce this numerical series. Here the running numbers are the denominator odd. Okay, let us make an attempt by setting x equal to 0. I'll repeat this expression again. The Fourier series modulus x equal to pi by 2 minus 4 by pi sigma n equal to 1, 3, 5 etc. infinity 1 by n square cos nx. If I give 0, that is set to 0, put x equal to 0, then 0, you can check the graph of the function. Or if I give x equal to 0, so what is the value? 0. If I give x equal to 0, this is also 0. So there is no discontinuity at all. Even though it's given like this, no problem. You can check there is no discontinuity. It passes through the origin. The modulus of 0 is 0. If I give 0 here, f of 0, modulus 0 is 0. So you know very well this. So I give different values. If I give x equal to 0, first give the value of x equal to 0, cos 0 is 1. So now vary the value, or we will rewrite this summation this side. When the bracket, give different values of n, that is only odd value exists. So you will get this particular thing equal to pi by 2. After cross multiplication and simplification, you will get the required value, pi square by 8. Yes. We'll do one more problem to gain some knowledge about even and odd function, how to apply. It's a very standard problem. Find the Fourier series for f of x 1 plus 2x by pi minus pi to 0, 1 minus 2x by pi 0 to pi. Hence deduce that this numerical series. You know the function. Take the function defined in the positive or negative form. That is, choice is left to you. Normally we take positive side. Take positive side of the function. Just feed minus x, or we will get automatically the negative other side. That shows the function is even. Therefore the function is even. You know the Fourier series for even combination. Then what is a naught? You know, 2 by pi. Substitute my function defined in the positive range 0 to pi. Yes, this is what I am substituting. You know integral dx is x. Integral x square by 2. The 2 by pi is common. I am taking out integral of x square by 2 get cancelled out, and if I substitute the limit, you will get a naught simply 0, get cancelled out. Next, let us calculate an. You know the formula for an, 2 by pi integral 0 to pi, and you know fx, the positive of 0 to pi, and cos nx dx. Apply Bernoulli's formula. You know the derivative of 1, 0, derivative of x 1, and then diluted. So I can put together entire thing using Bernoulli's formula. No need to split up. Let us take entire thing as u, write u as it is, integral cos sin nx by n minus the derivative of this, derivative of constant 0, the derivative of minus 2x by pi, just minus 2 by pi, derivative of x is 1. So I am closing the bracket, and integral value of sin nx by n minus cos nx by n square. I'm going to substitute the limit. You know very well by default this trigonometric function sine for multiples of pi as well as sine 0 0. Remember either 0 to 2 pi or 0 to pi you can score out, but not for off angles. Recall. Now my focus only on this term, only odd number of negative symbol. Take negative symbol around, simplify 2 by pi n square, or let it be 2 by pi cos nx by n square 0 to pi. The 2 by pi is common. Now I am going to allow the limit. So 2 by pi, I can simplify this entire thing as minus 4 by pi square. N square also I can take it out. My focus only on the function x cos nx dx 0 to pi. Now if I allow upper limit minus 1 power n cos n pi, lower limit cos 0 is 1. So I'll read it. Remember, next give different values of n. All odd value will get minus 2. So minus into minus plus. So plus 8. For all even value, this minus 1 whole square minus 1 0. You can check for all even combination diluted for all odd value. This bracketed expression is minus 2. Therefore minus 4 into minus 2 plus 8. So this is what we get finally, this an. After finding out a0 and an, then I'll rewrite what is an, and the Fourier series. Since a0 is 0, so just ignore, take only odd values. Take it out 8 by pi square. Write clearly. Now before deducing the numerical series, what we want to deduce the numerical series for this problem. I want to deduce this numerical series. That's what we have done in mod x, same thing. So by default you check x equal to 0. Always try whenever the cosine function you can think of setting x equal to 0. Give x equal to 0, f of 0, 8 by pi square. Yes, cos 0 is 1. Now allow the series, and f of 0. Now take the function, give x equal to 0. There is no discontinuity at all. You can check, give x equal to 0, 1 plus 2 into 0. So we'll get 1 only. Same thing here also. So both the combination, if I give x equal to 0, you will get a unique value 1. So therefore you will get f of 0 is 1. After that just cross multiply. That's all. Find the Fourier series for f of x equal to x minus x cube in the interval minus pi to pi. The total range is 2 pi and the function clearly defined. Let us check by, because the function defined minus pi to pi, we can check for odd or even. Let us say replace x by minus x. So we'll get minus x minus of minus x cube, which is nothing but minus x plus x cube. You can take it out minus symbol common, so x minus x cube. Therefore minus f of minus x equal to x minus x cube. So this is what we end up with for negative and the given problem. So when I replace, I'll get this. Therefore it's very clear, these two, from these two, f of x equal to minus of f of minus x. Therefore f of x is odd. If it is odd function, what to do? So if it is odd function, the Fourier series is very simple, single combination, n equal to 1 to infinity bn sine nx, where bn is 2 by pi integral 0 to pi function f of x sine nx dx. So when I substitute the function fx x minus x cube into sine nx dx 2 by pi, I am going to apply Bernoulli's formula. This is u, the second one is v. So x minus x cube integral sine minus cos nx by n minus the derivative of this 1 minus 3x square, and integral cos is minus sine nx by n square. And then it's alternating symbol, therefore plus the derivative of this entire bracket minus 6x and integral of minus sine cos nx by n cube, and one more term minus the derivative of this minus 6 and the integral of cos is sine nx by n power 4. So this is what the entire integral process. Really the Bernoulli is somewhat lengthy. Why? Because we are working with cubic term. So here the limits are integer multiples of pi. So you know very well, wherever sine function you can strike it out, this is also 0. Okay, now so we are going to find out the remaining thing. So let us take first upper limit pi minus of pi minus pi cube cos n pi. Cos n pi is minus 1 power n divided by n. Lower limit completely 0. Now here minus 6x. So minus 6 pi cos n pi minus 1 power n by n cube. So lower limit is also 0. So if possible you can simplify, otherwise this is what the entire thing. So some combination of thing. You can take LCM, or otherwise you can take it out pi common. If you take pi common, okay, so minus 1 minus pi square, I think minus 1 power n is also common, divided by n minus 6 times 6 by n cube minus 1 power n. I am taking minus 1 power n common, pi is also common. Maximum I can simplify. These two I can cancel it out. So 2 by n cube, take LCM. So 6 minus n square times 1 minus pi square minus 1 power n. So I am going to substitute in the Fourier series. Therefore x minus x cube, can take it out constant 2, and sigma n equal to 1 to infinity 6 minus n square 1 minus pi square divided by n cube followed by minus 1 power n sine nx. So this is what the Fourier series for x minus x cube is an odd function. So let us take another example for odd function. Let us find the Fourier series for f of x plus 1 in the positive range, x minus 1 in the negative range. Take f of x equal to x plus 1, replace x by minus x, yes, minus x plus 1, pull out minus symbol, this is what, and if you replace, just exchange the negative symbol, you will get x minus 1. So if you replace negative here, you will get back the other side with excess negative symbol, therefore function is odd. Therefore this odd function for Fourier series, you know, fx, and what is, you know, bn, I'll rewrite. Okay, now substitute the positive of the interval here, x plus 1 sine, apply Bernoulli's formula, you know very well, x plus 1, that is u, integrate sine minus cos nx by n, and so on. If I substitute upper and lower limit, this particular term completely collapse, and when I substitute upper limit, take it out minus symbol, pi plus 1 cos n pi minus 1 power n divided by n. If I substitute upper limit, negative symbol, pi plus 1 divided by n. Lower limit, there is a minus, so plus 0 plus 1, so 1 only. So there is a minus symbol for lower, so cos 0 is 1, 1 by n. So remember, there is already minus symbol, lower limit 1 more minus symbol plus. Then you take LCM, that is just take it out 1 by n, and rearrange, normally avoid negative symbol in the beginning, and then substitute. Don't need to simplify. Remember, if it is just 1 minus 1 power n, you can simplify. Otherwise, do not simplify, you won't get any reduction, that is you won't get any zero value since the pi value is present. So that's all your bn. Therefore you can substitute in the sine Fourier series for odd function. Thank you.